Hello everyone, welcome to VKS YouTube channel. In this video, we are just going to discuss all about ordinary least square. What is ordinary least square? The ordinary least square method, which minimizes the sum of square residual to find the optimal value. So first of all, look at this diagram. So here, this one is the one of the linear regression model. So this one is the one predicted line, whereas this predicted line is known as this part is the slope and this part is nothing but the intercept part. So here this one is the equation. With the help of this equation, we are just draw this linear regression line. Right now, our aim is to find out the optimal value for the intercept, like the B, this one the intercept, and coefficient like M in a linear regression model. So basically, let's go for the how we will find out the error. How we will just find out the error. So if we will just go for the error, let E1 error is equal to the actual part and then predicted part. So whereas if we will just talk about what exactly the yi and okay, so here yi, which is the actual value, and y high hat is nothing but the predicted part, predicted value. So here, if we'll talk about that predicted part, so here, if the data point is will be split like this, so these all are nothing but what? These all are nothing but the actual value. This data point which is splitted, these are the actual value, or you can say the estimated value. And if I want to just predict this one, the line, which is the predicted line. So here, this part is nothing but the predicted part. So right now, as we already know that, so there is a one equation, which is nothing but the what? Y equal to mx plus b. So as the m and b, which will be denoted as, let us assume, so I can also write like this, y like predicted line, which is equal to, this part is the predicted part. We are just predicting. Y predicted is equal to, I can also write the intercept plus b, mx. That one is the coefficient with, this x is nothing but the number of independent variable. Now, so I can just denote like b, which is equal to beta naught, which is equal to intercept. Same way, the m, which will be denoted as the beta 1, which is nothing but the coefficient or slope. So right now, let's go for the execution part. Go for the execution part. So here, if error is equal to actual value and the predicted value, whereas the predicted value part is what? This one. So if I will just write in this format, so then what? The y predicted is equal to beta naught, like the intercept plus beta 1 xi. So this part is nothing but the predicted part. So I can just put this value. I can just put this value directly here. So how to just put it? I can just write like this. Error is equal to the actual value negative. So here directly I can just put beta naught plus beta 1 xi, right? So now here I can say that the SSR, which is nothing but the sum of squared residual. This one is the sum of square residual, SSR, sum of square residual is equal to sum of error square. We are just squaring it, right? Sum of square residual error. These are the residual error. This one is the residual error. So we are just going to what? The sum of square. Because of sums of square, so I'm just squaring this part. Again, the sum of that whatever things is written here, same thing. So the actual value negative. Let's open the bracket. It will be beta, then negative, positive, negative. Then beta 1 xi is equal to, sorry, not is equal to, it will be square. This one will be square. So now this one is the SSR, means sum of square error. Finally, we just write. So now our goal is to find out the value of beta 1, right? Our goal is what? To find the beta naught and beta 1, right? Because of what? To minimize the SM. Okay. So we want to what? Minimize the SSR, sum of square residual. Because of it, so we are taking the partial derivative of SSR. With respect to whom? With respect to beta naught and with respect to beta 1. So let's go for that partial derivative with respect to beta naught. Means like intercept, you can say. So here, the final one is what? Final one is the SSR is equal to sum of error square, sum of actual value, then intercept, then coefficient, independent variable, whole square. So finally, this one is the previous one. Good. So now you have to derive this one. How I should just derive this one? So derivation of SSR with respect to whom? With respect to intercept. With respect to intercept. Now, if we'll just derive it, the first one derive, if we'll just derive this first one, okay, first one. So there is a 2 is there, right? So now the 2 will become outside. The 2 will become outside. And then again, as it is, yi, beta naught, beta 1, this one is the beta 1, xi. Now, again, just derive inside this one. So with respect to beta naught. So yi 0, negative 1, negative 0. So now the final one will be what? So 2 sum of yi, beta naught, beta 1, xi, and negative 1. So if we'll just finalize it, so negative 2 sum of yi is actual variable, intercept, coefficient, independent variable. So this one is the final equation 1. This one is the final equation 1. So now let's derive with respect to coefficient. So now we can say that partial derivatives with respect to beta 1, which is nothing but the slope or coefficient or coefficient. So the derivation of SSR divided by with respect to beta 1. So answer will become 1. Same thing. So you can just say that this part, okay? So I have to just write here. The 2 will become, and then same way, first actual value, intercept, coefficient, independent variable. Now derive this inside with respect to coefficient. So now it will be become 0 and 0, and then it will be become 1. So that's why xi. And now I can just say that, so beta naught, beta 1, and then it's negative xi. So I can also write like this: negative sum of yi, intercept, coefficient, independent variables, and xi. This one is the equation 2. Finally, we got two equations. Finally, we got the two equations. So let's write that two equations. So first equation, what is the equation 1? Equation 1 is the negative 2. So I can just say that like this. Let me just erase. Now I can say that the derivation of SSR with respect to beta naught is equal to negative 2 sum of actual, intercept is equal to this one. Now this one the equation 1. And now if we just go for the equation 2 with respect to beta 1, then negative 2 yi xi. This one is the equation. Now let's solve the equation 1 for beta naught. Like the goal is what? To find out the beta naught. Goal is to find out the beta naught. So now we have to solve the equation 1 for beta naught. So here the equation is this thing. This is the equation. So now I can say that if I will just isolate this intercept part, if I will just isolate this intercept part, wait my point. So here, if I will just isolate this intercept part, so I can also write like this. In beta naught, sum of yi negative beta I beta 1 xi beta 1 xi. So I can just write like this, right? So if I will just divide that n in both side, then it will be become like this. Beta naught is equal to sum of yi divided by n, then beta 1 xi divided by n. So now see, one point is what? One important point. Since this sum of yi divided by L is the mean of y. Same way, you can say that this part is the mean of x mean. So now we can also rewrite like this. So this part is the y mean and this part is the x mean. Okay. So now we can say that beta naught is equal to y mean and x mean. So finally we achieve the intercept formula. Now let's substitute the beta naught in equation 2 to get the formula for the coefficient. So right now we can say that, so we have to get that beta 1 is like coefficient. So now the formula is what with respect to 1? We get the 2 sum of actual, intercept, then coefficient, independent variable, and this one is the final equation, right? So now here, let's expand this one. If I will just expand it now, I can just write like this, the expanded form. So here, sum of xi, yi, negative. This part, listen, this part will be what? This part will be written like this. So if I will just write in this form, so I can also just put the value here. After putting the value, you can just write like this. So y, and then it will be multiplied. This part will be multiplied to these things also. Now, x, y mean sum of xi because of this one. And now, beta 1, this part, x mean, then again the sum of xi because of this part, and then next term, this part, the beta 1 sum of xi square, because xi will be become square is equal to 0. Now let's rearrange the term. Like for example, you are just looking that beta 1 and beta 1 is there. Okay. So now I can just write like this. How? Beta 1 will become common. It will be become common. Now, x mean sum of xi negative sum of xi square. Now, next is equal. So, y mean sum of xi negative sum of xi yi. So right now, let's solve for the beta 1. I can just write like this. Beta 1 is equal to y mean xi negative xi yi divided by x mean and then xi square. So now this is the things we just get. So let's introduce n. number of data points, right? So now if we will just introduce the n, now we have to what? Multiply that n into two sides. Like one is the numerator and next one is the denominator. Now, if we will just multiply n with the numerator and denominator, then we can just get what? The n y mean sum of xi. Again, the n sum of xi yi, and now divided by the n x mean sum of xi, then n sum of xi square. So since, as we already know that the n y mean, the n y mean is what? It can be sum of yi, can be written in sum of y, and the n x mean, it is what? The sum of xi, right? So now we can just say that, so beta 1 is equal to, just replace this one, just replace these two, okay? So sum of yi, and as it is, it will be written sum of xi negative. So negative in sum of xi yi, and now divided by sum of xi negative in sum of xi square. Now, if we will just rearrange these things, okay, how I should just rearrange? See, xi and y is there. Sum of what? I can just write like this. Sum of xi yi negative xi yi. Now divided by sum of xi square negative n sum of xi square. So let rearrange this one. So beta 1 is equal to, let alternate this one. Like I can also write like this, negative n sum of xi yi, then negative sum of xi, and then sum of yi. I can also write like this, divided by negative n sum of xi square negative sum of xi square. So here negative will be cancelled out. And now you can say that finally the coefficient in the linear regression model that often using the ordinary least square method. So these two are the method or the formula, you can say, with the help of whom you can just find out the intercept value and the coefficient value. As we just implemented using the Python, and we find out the intercept value and the coefficient value. Like then the mathematics behind of that code is this equation, this one equation and that next equations, right? These equations. So these two equations or these two formula you have to just remember, and hence I just proved how we just get these formulas. Hopefully you just cleared how exactly we just get this formula. So if you are having any doubts, so you can just ask me in the comment box. And if you just like the video, please do like and subscribe, and do share it with your friends. So maybe your friend will get help from this video. So thank you. Bye bye. We'll just meet in next video with the new concept.